Okay, announcement number one. This may be out of order, but I will have a review, and I've already mentioned this, I think, but I'm mentioning it again. A Zoom review for 11:10 tomorrow from 10 to 11:30 in the morning. Strictly 11:10. So I'm inviting my 11:20 students also. What I'm going to do tonight, and because I have nothing better to do on Friday nights now, I'm going to look at both exams and select the common concepts. For instance, everybody needs to know quantum numbers. So I'm going to create 20 to 25 sample problems that I'm going to review tomorrow, 10 to 11:30. That was announced Wednesday. I'm repeating myself. Sorry.
10:30 to 11:30? Okay.
I will send the link to that meeting tonight. Okay, that was announcement one. Announcement two. I emailed you guys, I thought, and I apologize if I didn't. I know I did it to a few of the classes. The average for test 5 for my 3 classes. PO1 had this is test 5, 72% average. PO2 had a 75% average. P21, which is my Tuesday, Thursday class, had a 79% average. Marshall, I think you're the one that asked for the averages, so I did that.
Thank you.
You're welcome. Let's see. Abdullah asked, oh, sorry. Okay, my dog might start barking because it's recycle garbage day. Maybe not. You are allowed to drop your lowest test grade. That means there are 400 points possible. You have a 50-point midterm. That's 50 points possible. You have, I'm taking the best 5 activities at 20 points each. That's 100 points possible. In lab, I believe, and correct me if I'm wrong, because I'm not teaching lab this semester. I believe the possible points for lab are 235. So when I add that up, hold on if I added it right, that's 785 possible points. You take your points to date, because most of the lab grades are in by now, just FYI. I mean, I know that Dr. Loom, Dr. Dana, Dr. Veith, Dr. Burns. Okay, I don't know about, gosh, what was his name? Dr. Hicks. I haven't received an email from him yet. But basically, if you have your last stuff you submitted by Saturday of this past weekend, if it's been graded, you can total your own points. It's out of, excuse me, what?
Sorry, okay. If I have like 600, I can divide this amount is by what?
By 785. 600 by 785. If you've got 600 points, divide it by 785.
By 780.
Guys, we're not going to go over everybody's individual grade right now. I wanted to use today as a review. Okay? So that answered Abdullah's question. Okay. Anybody else have a quick question before I answer your questions on review?
So how do people normally do on the final? Because you said that they don't normally do good on the midterm. Is it the same on the final since we don't get partial credit?
Do you happen to remember, I don't have my grade book up, what y'all's average on that midterm was? Does anybody happen to remember? No. The midterm average is a good predictor of what the final exam average will be. However, Dr. Burns, Dr. Veith, myself, all the 1110 lecture instructors got together on this final exam. I'm not referring to the midterm anymore because the midterm was mine. The final exam, and we tweaked it because we know this semester has been not normal. So the questions on the final exam, for lack of a better description, are more basic or simplistic, not as involved as any of my exams. And I've got a few sample things I'll show you in a minute. Concept-wise, I feel you guys need to do two things before you take that final. And you guys take it on Monday. Priority-wise, the first thing you need to do, I sent you guys recently an 1110 concepts packet where it lists on the first page words like resonance, sigma pi, electron configuration. That means you have a question on your final dealing with that concept. So then to help you out further, I created, 25 or so, 25 kind of questions or problems. If you truly work it, that is your best study guide for this final. Now, I'm not saying that any of the, if you're working the limiting reactant on this packet, you're not going to have a limiting reactant that involved. You will not. But I'm forcing you to study that concept. Are you following what I'm trying to say? Felicia has probably already done the packet. I can answer questions today from the packet. The second thing, if you have time to review, I sent you guys early on, a sample. It says it's Chemistry 1110 practice for final exam. I sent you one, it was called student copy. And then I sent you one with the answers bold typed or, bolded, whatever. So like the first answer is letter B. I'd look over this. If you do just that, there is no reason you're going to make below a 70 on the final. I am getting ready. Oh, here is an announcement. I will send out an email Sunday on where this exam is actually located. It is set up on PO1 right now in D2L. But what we might do, because we did it for 1120, we may set it up on the 1110 merged lab site where y'all check for your videos for lab and all that. That site under quizzes, but watch for an email from me. I'm also today, after I've got 3 lectures today, after my 3rd lecture, I'm going to send you guys I'm going to forward something I got from HonorLock last night. And it is very good information for students. And I'm going to forward that. I've already forwarded some stuff, but this sort of sums it all up. So be watching for an email at around, matter of fact, I'm going to make a note.
Like, can we send like, you send like practice to test our equipment, like in the engineering, they send like practice to test my camera, my equipment.
It's the same practice for everybody. It is the same practice for everybody.
Okay.
4 questions. Are you going to be honest? Yeah, it's the same practice.
Okay.
Yeah. And that was already sent. Y'all could actually look that up in the link.
Oh, you already sent this practice on D2L?
No, I did not send a practice on D2L. I sent y'all a link, an email. Okay, let me ask this. Have any of you seen the email that I sent earlier about HonorLock?
No, you send like a link about if I need equipment. I mean, like there is a link when I go inside it, check my camera, check my windows, check everything is good, take a picture of my face
Okay, I'll write this down.
because they, yeah, for the camera. Yesterday I went to the campus and they bring box. They give the student free camera, not free, like a good camera for 100. They give me one now. I tried yesterday. It works. Just I need to make sure. Just if you send the practice, it works.
Did you do it for your engineering science class?
For engineering science, I use my phone as camera.
Can you, okay, never mind. I will send the practice to everybody.
Yeah, just to keep safe, like for everyone, because if not, in the beginning of the exam, it will say, oh, it's errors. The equipment doesn't match the Windows, because some people have Windows Mac, Windows 8. The browser must be Chrome, they say. We
Right, it
can
has
use
to be
browser. Yeah.
Chrome. It
Yeah.
does have to be Chrome.
Yeah.
I thought I sent an email already, but you know what? I'll go back and send another.
Mhm.
Gosh, I've lost what I was even saying. What was I going over?
The review, and you will send email.
Okay. I think that's enough of my announcements. Do y'all have any questions on chapter 12? We'll go with that first. I think on Wednesday, I went over all of your test 5. Did I go over how to do test 5? Somebody answer.
Okay, the chapter 12.
Yeah, you did. You went over chapter 5.
Thank you, Eric. Thank you. On Wednesday, I pulled up Chem 101 and we did all of test 5. Thank you.
Okay.
That was done on Wednesday. Okay, chapter 12, you guys were not formally tested on. But there are at least 2 questions about phase diagrams and 2 questions about intermolecular forces. So I'm now asking, do y'all have any last-minute questions about phase change or phase diagram or intermolecular forces? I think we went over that on Wednesday also, but go ahead, Francois, you have a question?
Yes, ma'am. Can you do a simple problem about one that can be in the final for us, please?
Which one? Intermolecular force,
Yes, ma'am.
phase diagram, or phase change?
Um, 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 phase change.
Okay.
Um, if you don't mind.
No, I don't mind. I actually, okay, I'm just gonna make up another one. I'm gonna do this sample, and this is what I mean about tomorrow. I'm gonna do 20 or 25 of these, but we're gonna do one now.
Okay.
Okay, let me just write it out. And then we'll solve it. Let's see what we want. Okay. I've got a line drawn. I'm gonna write my question. And then we'll solve it. Okay, here's my question. Oops. How much heat is needed to take 10 grams of ice at -5 degrees Celsius up to liquid water at, I think that says 24.0? Do y'all see my question?
Yes.
Yes, ma'am.
Okay. Now, what I'm going to do, in my little line that I drew, I just wrote 3 steps. Step 1, step 2, step 3. Do y'all see that?
Yes.
Okay.
Yes.
Then all I do, I'm now going to number on this other sheet of paper. This is what I mean about what I'm going to do, 20 or 25 of them tomorrow. I'm going to write what I'm plugging in. Let me write the numbers, and then I'll hold it up. I thought we did one of these on Wednesday, but maybe not.
I don't know if you did one. I think you just kind of worked it out as a note. You didn't give us one to just practice on.
That's fine. I had a big review with my Tuesday, Thursday people yesterday. Okay, step 1 involved a temperature change. Mass, specific heat of ice. These numbers here in the middle, guys, will be provided in the problem. Mass, specific heat of ice, temperature change. Step 2, no temperature change. It said 0 and 0. Mass, heat of fusion, that number will be provided. Step 3, mass, specific heat of liquid water, provided, temperature change. Now, all 3 of these have a final unit of joules, joules, joules. You simply add them together. Do you need me to multiply it out and add them up? Anybody?
No, man. Thank you.
This is typical on your final. So you know what I'm going to do? I'm putting this on the floor now. 1 question down that I'll probably review. 24 more to go for tomorrow. Hold on, let me let this person in. Next question.
Like there's concept question about chapter 12.
Yes. Let me grab. Yeah. You're referring to the fill in the blank part?
I did the blank spot, but I have a question about the intermolecular forces. Like there's definition or something about it. The diplo, I don't know about this stuff.
Can you tell me the number you're referring to?
Yeah, is hold on. Okay, like the sorry. Okay, the question 7. Which compound has the high boiling point? How we will figure out the higher boiling point by the molar mass? Like which one has high molar mass?
Okay, guess what, Abdullah? We did this on Wednesday.
Mm.
Did you watch the recording? You weren't here on Wednesday. Did you watch the recording?
No.
Okay, I'm going to do it again. This is the type question on your final exam.
Okay.
Let me write the trend below.
That's fine. If the recording lecture, I will see. I will go.
No, I'm going to go ahead and do it because it's a question. It's the concept you need to know.
Yeah. Okay.
Actually, we'll see if anybody else in the class remembers. Okay. Between these 2 compounds, it wants to know, hold on, which one has the higher boiling point?
What? Water.
Okay, thank you, Francois. Why?
Because the molar mass is high.
According to my trend, intermolecular force gets stronger as molar mass gets bigger, hey, this has the bigger molar mass, boiling point gets higher, vapor pressure gets lower. But notice what I wrote below here. The exception is due to hydrogen bonds. Water will hydrogen bond. Dihydrogen sulfide will not. Do y'all remember me going over this? I'm going to draw it. I'm gonna
Yeah.
draw it. Thank you, Francois. I know. Okay, here we go. I'm going to use, remember, I think I even used a little blue marker. Water can hydrogen bond to itself because when you draw water, hydrogen is bonded to either NO or F, nitrogen, oxygen, or fluorine. If you draw a picture that has hydrogen bonded to nitrogen or oxygen or fluorine, we don't care what its molar mass is, it has a high boiling point. Questions? I'm going to put this down here. This is giving me ideas of what to review tomorrow. This is a repeat, guys. Come on, somebody else ask a question that maybe y'all have actually, I didn't do on Wednesday.
I'm looking at number 17 on the review, if you
Okay.
have a sec.
17 on that chapter 12 review?
No, the final exam.
Okay, thank you. Okay. Okay, let's go to number 17. Okay, I see it now. Is it the one that says zinc?
Yes.
Okay. It gives you a mass of zinc. It tells you it's reacting with chloric acid. Okay, we're going to go ahead and work this one. This is a good one. Thank you, Eric. I like doing something that I'm not repeating myself. I'm going to write the reaction first.
Is that
It's
going to
not-
be zinc plus HCl3 is then the arrow to zinc chloride? I don't know why I'm blanking. Zinc chlorate plus H2?
Yes, there you go. You just said it. Thank you.
Okay.
That's the reaction. Now, I haven't balanced it. It is going to need to be balanced.
Yeah.
What is the reaction type?
See, I think that's single replacement, but I don't know if I need to go any deeper than that.
No, it's single replacement.
Okay.
Yeah, perfect. Single replacement. Now let's go ahead and balance. Oh, well, all I had to do was this 2, right? We got it balanced.
Oh, it's just.
I'm sorry. I balanced it because if you have 2 hydrogens here, because it's diatomic, you need 2 there.
I guess I wasn't sure what it says zinc, but it didn't say zinc 2, so I didn't realize the charge was 2 for.
I'm glad you're mentioning this. There are 3 transition metals that have fixed oxidation states. Zinc is always a +2 in a compound. Cadmium is always a +2 in a compound. Silver, always a +1 in a compound. Y'all need to know that. You know what? That's why I put this on here. There are 3.
Yeah, I think on the Chem 101 test, you had silver in a compound, and it kind of threw me off for a minute before
I
figured
had
it out.
silver in a compound. Right. Silver is always a +1 in a compound. Always.
Can you show the chemical equation one more time? The
Yeah.
zinc one you just held up.
Yeah. Do I need to raise it up or move it back, or is this
No,
good?
it's perfect. I just didn't catch the hydrogen at the end.
Okay. Yeah, because what happens, this metal is located above hydrogen on that activity series. So it's going to kick the hydrogen out. That's why it's called a single replacement. Okay, now I'm going to write, we start you with 0.234 grams of zinc. Let me just write it out and then I'll hold it up. This is how you would solve it. And it wanted to know what volume of hydrogen may be produced at STP. Okay, whose mic is on that we hear all this stuff? Here we go. The mass of zinc converted to moles using, this is the molar mass on the periodic table. It's a 1-to-1 mole ratio. STP is 22.4 liters per mole. This is a typical type question. I will say this. We would probably give you the reaction already balanced. We're just asking you to do this. All the questions on the final exam are not, how can I say it? If we want to see if you have balancing ability, then we're just going to ask you balance that. We would not ask you to balance and do a stoichiometric problem on one problem, if that makes sense. I will say you need to always verify that the reaction has been balanced. There may be one question that gives you the reaction and asks you something simpler than this, and it says something like, calculate this, the number of moles for the unbalanced reaction given. Like, hint, 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 you guys need to balance it. Am I making sense what I'm trying to say here?
Yes, ma'am.
Okay. So Eric, did I answer your question on number 17?
Yes, I've been trying to do these without looking at crazy amount, and I forgot STP. So I got to the mole ratio without the STP.
Right, that's fine. Okay, next question. Anybody? It can be from this review packet that Eric just asked, or it can be from your practice final exam packet that I emailed you. Anything? Questions?
I got a question about the diversity problem. It's pretty simple, but I think not can you go just tell me this step to do because I do it in my answer, it doesn't match yours.
Okay, which problem? I'm sorry, which number?
The first one, the first
On that review packet?
Yes, ma'am.
Okay.
You don't have to do it. Just tell me this step because I feel like I was
let me just write the
You're doing
numbers
it right.
up, and then
Okay.
you can tell me if you didn't write the numbers right.
Which problem is this?
I think he's talking about number 1, the specific heat problem.
Yes, ma'am.
Okay. Let me write the numbers, and then you tell me what you didn't write. Oh, I didn't give it. Did I give an answer to this problem? Did I give y'all an answer to this problem?
I think you did because
No.
there's something in red next to it.
Okay, yeah. Let me just write the two possible. You'll see.
I've got negative 1.41 times 10 to the third.
Yes,
Is what you've
there
got
it
here.
is. Okay, here we go.
Okay.
The temperature change final minus initial is going to give you a negative number. That way we know heat was released. Heat equal mass, specific heat given. Yes, it's calories per gram degree Celsius. Temperature change. That's your calorie answer. Oh, I didn't write. You have to convert it. I'm sorry, I didn't write the conversion. Let me write it. So what is it? It's 4.184 joules per 1 calorie. There.
Okay, that makes sense.
That's how you do.
So
Yeah.
what I was confused is because when the problem I've been doing when there is like negative, it's when there's like a two side, and I was confused because I was like, why this is
Negative.
negative? But yeah, but it never it clicked me. It's because like um 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 heat was being released. So now I get it.
Okay, good. Yes, it's negative if heat is released. It's positive if heat is needed.
Yeah, now I get it. Thank you.
Okay, perfect. Okay. Felicia, pay attention to that part for your 1120 test.
Yes, I will.
Okay, next question.
I was looking at the final exam practice that you emailed us.
Yes.
And, on number 3, it says based on the molecular formula, what is the hybridization of each carbon atom in the molecule?
Yes.
Like I understand, how to figure out the hybridization, but like, is there going to be like a lot of questions like that? Because it just seems like it's weirdly worded.
Right. No, this was guided more for a review packet. This would be a sample on your, hold on, let me write one up. This would be an example of what we would ask on your final. On this molecule here, what would the hybridization of this carbon be? A, B, C, D. Okay, what you would have to do is you have to draw it, obviously on your scrap paper. Let me put my hydrogens in. And then you tell me what the hybridization would be. This is more what we do. And also, Felicia, on your test, you have to draw it and figure it out. Okay, we only want the hybridization here. What would you say the hybridization for this carbon here is?
SP3.
Yeah, it's sp3. So Marshall, did I answer your question? Basically,
Yeah.
you will have to draw it. Oh, how about if I back it up? On that particular practice you're referring to, it says use the information below to answer 1 through 4. We didn't do that. Every question has its own question. It's not a chain of questions.
Okay. I think I printed off the one with answers on it just so I didn't have to print off like 2 big packets. So I guess the one with answers doesn't have all the information for the questions on it.
It doesn't?
I guess not. I don't know. That might be why I'm confused on so many of them.
Yeah.
Say that. Which packet?
It's this one. Can y'all, oh, sorry, my pencil keeps. It says practice for final exam with answers.
Yeah, the bold ones are the answers, correct?
Yes.
Yeah.
But Marsh,
On 3, like on 3, there's like, is there any formula that goes with that question?
oh yeah, it's the answer above.
Okay.
They remember
Okay.
that's what I'm saying. 1, 2, 3, 4 all go to that.
Okay.
Does that make sense?
Yeah.
Okay. I think that was the only, hold on, because it's been a while. That's the only one that involves more than one question with the problem. Yeah. Okay. Okay. Let me do one more of these because let me just do some. Oops. Okay. We might hear my dog here in a minute. Let me just do one. This is the kind of thing that I would do in a review anyway. I can ask several questions on this molecule. Okay, I've just drawn, and Felicia, pay attention to this. If a molecule is drawn for you guys on your test, and they simply ask, for instance, what are the bond angles around the nitrogen? What would y'all say?
$120.
120.
No. That would have been a
less
choice.
than 120 because it has the yeah, it'd be less than 120 because it has the lone pair.
Right, it's going to be close to 109. Y'all remember that 1, 2, 3, 4 regions around it?
Yeah, now I get it.
Okay, well, wait, let's keep on going. What's the hybridization of this carbon? This first one?
SP.
SP. Perfect. Let me do another. What's the bond angle around this carbon here where my finger is? This one here. What would the bond angles be?
It's the 121, correct?
Correct.
Because there's
Not
only
that-
3.
It's 120 because there's 3 regions around it. Okay, one more. What would the bond angle for the second carbon be? So I'm talking about this bond angle right here, this one.
180.
Yeah, not that we would ask all those different questions for one molecule, but that's the concept. You'll have a molecule and they'll ask one question, whether it's hybridization or bond angle. Oh, here's one. Hold on, let me count it.
Was that the SP bond? Was that for the the first carbon in the hydrogen? Is that what that was?
Yeah, this would be SP, SP, SP2, SP2, 180, 180, 120, 120, little less than 109. Now, how many sigma bonds and how many pi bonds?
3 pies.
Okay,
And
there's
9
3.
sigmas.
Yes, 9 sigma and 3 pi. You are correct. I'm going to save this too. That's going to tell me what to review. Plus everybody, even Felicia, you need to know sigma pi, hybridization, and bond angles. There we go. This is
Yep.
good. I like this kind of review, guys. Keep going. Come on, we can do this. What else?
Can you go over an empirical formula one?
An empirical formula? Yeah. Is that what you said? I'm sorry, Marshall, is that what you said? Empirical formula?
Yeah, that's what he said.
Okay.
Yeah, I saw one on the practice, but I don't remember what number it was, so I'm looking for it right now.
I'll just make up one, okay? Okay, hold on. Okay, step 1. How would you, the student, if I give you that a compound contains carbon, hydrogen, oxygen, but I'm only giving you the percent of carbon, the percent of hydrogen, how would you get that?
You would add the percentage of carbon with hydrogen, and then you're gonna subtract it from 100.
Correct. And if I did it right, okay. I think it's 53.33. Okay, so what I did, I based it on 100 gram. I just dropped the percent and added the gram unit. Do you understand what I just did there?
Yes, ma'am.
Okay, then what I do is I look on my chart for their molar masses. So let me write them up and then I'll hold it back up. Okay, so I look on the periodic table and carbon has 12.0. Oh, you are obeying how many digits in your measurement, okay? This one is 1.01. This one is 16.00. And then you do the number, you divide it out. Okay, now I'm going to ask the class, what would you do now if you've got these 3 mole values? What would your next step be?
you're gonna divide it by the smallest one.
Okay,
By
so
the
I'm going to
average.
divide, I guess I'll divide everything by this number right here.
Yeah, by 3.33.
Okay, let me do it. So 2 of them hit 1. And what is 6? It should be 2, but let's just do it, make sure I made, okay. Okay, question to the class. Is this close enough to 2?
Yes.
Yeah.
Okay, so that means it's C2, it's CH2O. So that molar mass is 12, 13, 14, 30. Okay. Now, question to the class. That's called the empirical formula because that's the most reduced form. What if I tell you, but wait, the true formula is 180 grams per mole. Let's say I tell you, well, wait, the true compound is 180 grams per mole. What would you do?
Double it.
Double it?
No, it will be more. Like you have to like triple it. I don't know.
Well, come on,
By 6.
by 6.
But by
Francois,
I can't do math.
Yeah,
That's
you
what I have to
can.
do with double
You
or
can,
triple.
look.
I want to do something. That's what I have
It's
to do something.
180 over 30, so you would multiply all of this by 6.
Yeah, I know it is step, but I don't know what you would like multiply it with to get it close or over to 180. That's what I said, like double,
But
triple.
do you understand? Do you understand what I did here?
Yeah, that's simple to get it. What to
Okay, wait,
multiply it with.
okay, let me do something else. Let's say I'm just making up something. Okay, hold on. Let's say we have a different compound and the mole numbers are 1.00, 1.25. Oh, wait, let me make it a little bit harder. Sorry. Y'all notice I have a step in my pep. You know why? This is my last Zoom day.
Yeah, I can tell.
Okay, here we go. 1.00, 1.25, 2.03. What would you do here? What would this be close to?
1,
1. What would this be close to?
2.
2.
Okay, I'm gonna write that. Okay. What in the world do I have to do to this one?
You take
Multiply it by 4.
Yes, and if you multiply that by 4, you better multiply the others by 4. So you
That's
get a
right.
4, what is that, a 5, and an 8. Could y'all follow what I just did there?
Yes, ma'am.
Okay, perfect. I'm gonna save that too. Y'all are giving me great ideas.
and the 1.25, let's say it was like 1.32, you just take 100 and divide it by that number and it gives you the one that you times it by.
Yeah, but gosh, that would be 1.32 times.
I was just
3.
making up a number.
No, that you're right. That's what you would do. I was just making sure it would hit close enough, but it does.
So I got a question, but I don't remember the chapter that it's under. Okay,
Uh-huh.
do you remember those problem where like they give you an equation and then they give you 2 or 3 others and then you have to fix them to make it equal to the one they give you?
Oh, Hess's law?
Exactly. Can you do one like that, but with 3 equations? Like I can do it with 2 easily, but with 3 I always have a hard of time to do it.
Okay. These are hard for me just to make up. Oh gosh.
Oh, you can do one
Tomorrow?
yes, ma'am. Tomorrow. Be
Well,
fine.
here's one. Wait a minute. Can I do the one that's in the review packet? Because there's 3 there.
Sure.
Okay. So this is the goal. Let me write it. Yeah, everybody has one of these on their final, Felicia.
Which problem are you looking at? Is that
Number
20?
23, number 23. This is going to take me a minute to write it. Just bear with me. I'm not going to write the physical states. Y'all can look it up, okay? Just to save some time. But I'll do this slowly so you can see what I'm doing. Did anybody happen to go ahead and do this one? Eric, did you already do it or no?
I'm not that far yet. I'm looking at it though.
It's fine. It's just, it's possible I could have made a mistake, a number mistake, but we'll see in a minute. Okay. Okay, here, and correct me. Okay, this is my goal. My goal reaction. I want methane and ammonia on the left, and this hydrogen cyanide, and what is that? Hydrogen on the right.
Yeah.
They give me 3 reactions. They give me 3 numbers.
Yeah.
Okay. The rules are, if you flip a reaction, if you reverse it, you must change the sign. That's rule 1. The second rule is, say I'm making this up, say I double all of this, then I have to double that number.
Yeah.
Okay, great. Now, this is messy. It looks like ammonia is on the left, so I already know I have to flip that whole reaction.
Yeah.
If I flip it, I have to change that sign. So you know what I'm going to do? I'm going to do a little squiggle line through that reaction, and above it, I'm going to write what I've done. This is going to it's going to get messy fast, but we'll just try it. All I did was I reversed the reaction and changed the sign. Do we agree?
Yes, ma'am.
Okay. Hold on. It looks like methane, or CH4, is on the right, but I need it on the left. I have to flip that one too.
Yeah.
Okay, good. I'm going to flip it. I'm going to write it above. Okay. And then if I flip it, I have to change the sign.
Correct.
Okay, so so all I did is I reversed it and changed the sign. Hold on. It looks like HCN is on the right and I need it on the right. Do we agree?
Yeah.
So what I'm going to do there, I'm going to leave it alone.
You need to divide that by 2 because your ending problem only has 1.
I'm not going to divide it by 2 yet, because if I multiply this middle one by 2 and then add them up, I can divide the whole reaction by 2.
Okay, so that's what messed me up on the
Me
test
too.
for this.
Me too. That's why, like, I divided by 2 and I'm like, I'm not getting the
Right.
right answer.
Yeah,
Maybe,
yeah.
maybe I'm doing something wrong.
Do not divide until the very
Okay.
Well, I guess on the Chem 101, they were dividing like up in the problem by making fractions because I couldn't ever figure out how to get the right.
You can, and then what's going to happen if you have a half of oxygen here and a half there, or 3 halves there, you understand what I'm saying? Then you're going to have to work in terms of fractions.
Correct.
It's better if I see, here, look at this hint. If I see a 2 here, but I only need 1, okay, just hear me out. And I see, where is it? Where's the HCN? Sorry.
Very bottom.
Yeah, if I see a 2 there, sort of leave it alone. If I go ahead and double all that, things are going to start canceling. If I double this, which I'm going to go ahead and say, I'm going to go ahead and put a big 2. I'm going to distribute through. Okay, I'm going to double 2 in front of the methane, 2 in front of the carbon, 4 now in front of the hydrogen, and I'm going to put a 2. Look what I did, guys. I put 2, 2, and then 2 times 2 is 4, and then I doubled that. Y'all see what I've done?
Yes.
Now, when I look at it, I can cancel, let's see, what am I can cancel 2 carbons, right? One's on the left, one's on the right. What else can I cancel? A nitrogen. One's on the right, one's on the left. Are y'all following what I'm doing?
Yes.
Now, hydrogen-wise, what do I have? It looks like I have to flip it. I'm sorry. I
You
have,
have 3 or 5 up top and then 1 in the bottom.
no, for hydrogens, it looks like I have 7 on the right and 1 on the left.
Oh,
Look,
that's right. I didn't.
don't I have
yeah.
7 and then 1? So that's a net of, sorry, 6 over here. So
Carl,
when I add them up, okay, I'm going to now add. I have 2 ammonias. My nitrogen's canceled. My carbon's canceled. My net hydrogens are on the other side. Okay, wait. And then I have 2 CH4s, arrow. What did we say? We had 7 less 1, so we have 6 hydrogens, and then 2 HCNs. Now, what I would do, don't do anything here yet. You add these numbers up. You get a number. And then all I have to do is divide all of this by 2. I get my goal. Whatever this number was here, I divide by 2. Does that make sense?
yeah.
Okay, well, that's how you do them. I'm going to save, actually, I don't need, well, I'll put it down here. Okay.
Thank you.
Oh, you're welcome. I don't think the one on your final, either 1110 or 1120 is that involved, but the process is the same. Okay, next question.
I have one that isn't in the practice final review.
Okay.
Can you do Lewis dot structure on ions like the hydroxide ion or the cyanide ion?
Yeah. Okay. I'll do them on both. I'm gonna start it. Okay. I'm gonna do the hydroxide first. Oxygen has 6. Do we agree with that?
Yes.
Okay. I'm going to put a hydrogen, and it really doesn't matter. I put a hydrogen here. This negative means I'm allowed to add an electron. If I do that, I show the chart. I show somebody that, hey, I've added an electron to my picture. This is a polar covalent bond. This is an ion, so it's not a molecule. Are we good with that?
Yes, ma'am.
Okay. On the other one, this is gonna, let me just do it. I'm gonna do dots for my nitrogen. Let me erase this because I had an X. Sorry. Okay, I'm just starting my picture. Carbon is 4s2p1p2. Nitrogen is s2p1p2p3. Do we understand what I just did there? I haven't joined them yet. I am allowed to move these X's around this carbon. I am allowed to move these dots around the nitrogen. My goal is each one of these needs to be happy with 8. I am allowed to put an electron in my picture. Are y'all hearing what I'm saying there?
Yes.
Okay, then what happens, I'm going to do it down here. Okay, this is exaggerated. I'm keeping a lone pair on carbon and I'm keeping a lone pair on nitrogen. These 5 dots are nitrogens. These 4 X's are carbons, but something's wrong. What's wrong and what's missing?
An electron.
Exactly. So I'm going to add the electron. Look at what I did. Oh, let me show, I've added it. I added the electron. I show myself I did that. I have a triple bond here. A triple polar covalent bond. Actually, yeah, it would be triple polar covalent. Felicia, did you understand that?
Yes, ma'am. Thank you very much.
You're welcome. I'm wondering if I even need to save this paper. Well, I'll go through it later. Another question. Let me say, guys, go ahead. I'm sorry.
I'll say it just because if you had time to run through number 21. I know we're kind of getting at the end of it, and that's on the exam review.
Does it say 16 grams of oxygen, that one?
Yes.
Okay. How about, well, I'll set it up. You take your 16 grams of oxygen, which is diatomic. Guys, if you forget your diatomics on this final, you've missed 4 or 5 questions. Because one of the choices is that the student forgot. I'm just saying. Okay, let me just write these up. What is it? 10.1 grams of neon, and that must be 20.2. So it looks like I have, let me write it up and then I'll hold the sheet up. Do you guys agree, if I have these 2 gases, I have to convert them to moles, and my total moles now is 1.00 or 1.000. Do y'all agree with that?
Correct.
Okay, well, good. Okay, watch what I'm gonna do. PV equals nRT, V equals nRT over P. The N is 1. R, you know. I've run out of room for my unit. I'll squeeze it, sorry. Temperature, oh, temperature you gotta convert. One of the choices on your final is that the student forgets to convert it. So that would be 297.6. Okay, and then what was the pressure? 5 atmospheres. Here. We give you, N you just figured out. N you figured out. It wants V, so if you have this very famous ideal gas law, you're manipulating it. V equals N, which is 1 mole. R, you know. T, where is it? I had to convert. Pressure was given as 5 atmospheres. The answer should be 4.89.
So when it says exerting a total pressure, you just got to add those 2 up, and that's what will bring the moles in.
Right, because
Because it's additive.
yeah. If this is total moles, this is total pressure. Does that,
Gotcha.
did I
Yeah.
answer?
Yeah.
Okay. Yeah. There's one like this on your final. Matter of fact, I mean, I didn't create this packet.
Ma'am, can you hold the sheet up again, please?
Oh, that sheet up?
Yes, ma'am, if you don't mind. Bring it down a little bit. Thank you.
And did you
Thank
say
you so much.
the review was going to be 10 to 11:30
Yeah,
tomorrow?
I think I
Okay.
can get it done in an hour and a half. I mean, if we go a little bit longer, we go a little bit longer. But what I'm going to do, and just a heads up, guys, I will not be able to cover everything from your final. And I won't be able to cover everything from the 11:20 final. What I'm going to do tonight is look at the concepts that are common to both and create sample problems. Does that make sense what I plan to do?
Correct. Yes, ma'am.
That's what I'm going to do. And had we met, you know, on campus, I would have done a 9 to 10:30, 11:10, and a 10:30 to noon, 11:20. I can only do an hour and a half or so Saturday, but I'm going to announce to my 11:20 people, I'm going to hold a Zoom review Tuesday night, mainly for my night students. They just took their last test last night. They are way behind because of that flooding, the cancellation of a Thursday night due to the rain we had before break. Anyway, so I'm going to have to end the meeting, guys. Felicia, thank you for recording. You can stop recording. I've got to end the meeting because I've got a class in 9 minutes.